You'll know whenever it's recording because it says recording up there. You know, it's super fancy. You know, I don't have any catchphrase. Usually all the videos start off with me going, okay, let's get started. Alright, so we're going to start with basic geometric stuff. This stuff is all review. It's all very basic. Yeah, easy. So we're going to start with Pythagorean theorem. So Pythagorean theorem, the most basic form of it is a squared plus b squared equals c squared. The only one that really matters is your c. Your c has to be your hypotenuse. C is the only one that is not used to form the right angle. If you need any help with remember which one's the hypotenuse. Hypotenuse is not used to form the right angle. Okay, now if I put this on a coordinate grid and I gave each of these ordered pairs, okay, what would be the ordered pair right here? No, it wouldn't be x, or it would not be 0, 0. If it was 0, 0, that means this point would be 0 and this point would be 0. X2, Y1. Okay, these are, okay, here, let me put, if I'm counting over, since these are the same distance over, they would have the same x value, correct? So, since the value of this point is x2, the value of this point would be x2. Likewise, going up and down, if the height, oops, I wrote that wrong, sorry, y1. If the height of this value here is y1, then the height of this value here is y1, because they have the same height. Okay, I have a point to this. We'll get to the point. Trust me. Okay, so now each of these is a length of that side, right? So what's another way I can write those lengths? So A is the length of this side. So what's another way I can write that length? Yeah. X1 minus X2. Okay, so how about B? Not X's. Yeah, the Y's. Because X would be our horizontal distance. If we want a vertical distance, we go to our Y values. Okay, now but C, we can't really use that for C because C is slanted, right? Okay, so if I want to know what C is, I could find C by solving for it. So to find C, I could square root both sides. Now, do you know what that's called? Distance formula. That's how you get your distance formula. The only difference with the distance formula is we use a D instead of a C because we want our letters to have meaning. Now, the other thing, which I'll explain here in a little bit, is I'm going to use x2 instead of x1 whenever I do that there. Now, there's two reasons I can change that around. One reason is because it's entirely arbitrary. I made up those variables, right? I decided to label that one x1. Well, you know, I can just change it around and say, well, I want this one to be x2 and this one to be x1. Great, now it's changed. You know, wherever I'm making up variables, I could say this one's happy face and this one's sad face. Well, then I have happy face minus sad face, and then I don't have any x's because I don't like the letter X. It did me wrong whenever I was young. The other reason is, since I'm squaring it, it really doesn't matter. Order inside these doesn't matter at all. If I take 10 minus 5 squared, that's 5 squared, which is 25. Or if I take 5 minus 10 squared, that's negative 5 squared, which is 25. So since I'm squaring them, it really doesn't matter what order I put the numbers in. I can keep the variables exactly how I have them and switch the order around just because I want the 2's to come first. Still doesn't matter. Okay, so that's where distance formula comes from. It's just an extension of the Pythagorean theorem. So if you didn't know that before, in pre-calc, we're all about you learning where things come from. Whether you wanted to or not. Wait until we get to the quadratic formula. You will hate yourself. Alright, am I okay to move on? If I ever get going too fast and I start flipping through the pages, just tell me to stop, say, I didn't get that yet, and I will put the page back up and you can get it. Or if it's been too long, I'll say, okay, I'll get you that page here in a second. Okay, so I just want to do a couple examples. We're going to use distance formula and find the distance between these 2 points. I really just wanted you to have example in your book. Pythagorean theorem, I didn't figure you needed any examples, so I just skipped that one. Really, we skipped a lot in the book because your book started off with plotting points. I'm not going to plot points for you guys. If you can't plot points, you are in the wrong class. Okay, so put the x's in there first. Doesn't matter. I want to keep my numbers positive, so I'm going to put the 7 first. Again, I like positive numbers, so why do I have a plus in there instead of a minus? Okay, minus and negative 5. Again, if with a lot of this stuff, I'm going to skip steps. Again, that's an assumption on my part. If I ever go too fast or skip something and you don't see how it came about, you ask questions. Make sure I explain it. If you have a question about how something got there, most likely someone else does. And they're just too scared to speak up, so you speak up for them. Which, from using this one first to using this one first? just to prove that it didn't matter. I did it on purpose. I chose at the beginning to make sure all these came out positive, and with this, since we're squaring it, it does not matter. So I just did it on purpose to prove the point that it doesn't matter. Let's see, 9 and 9 make 18. Now, we haven't talked about simplifying square roots yet, so you do not have to simplify your square roots yet. We will talk about them. If you want to simplify your square roots, fine. If you want to give me a decimal, fine. One way or another, it needs to be simplified. Do not leave it a square root of 18. So, I either want 3 square root of 2 or the decimal equivalent of that. I don't have a calculator, so I don't know what the decimal equivalent is. You don't need to give it to me because I assume you guys can put it in a calculator and get the decimal equivalent. Just know that I want one of those two things. So either that or 4 point whatever it is. The other thing to watch out for in your calculators, I'm hoping you guys know this, but sometimes people don't. In your calculator, if you take negative 3 squared, it is going to tell you that that equals negative 9. That does not equal negative 9. Because your calculator does order of operations. It says to order of operations says exponents first. It sees this as a multiplication. It sees that as taking negative 1 times 3. If you want to actually take negative 3 squared, you have to do it like that. Then it will give you positive 9. So just be aware of that and be careful of that, because every year I see mistakes where someone gets negative 3 here and then they give me 0 for a distance. So just be careful of that. All right, this one, I want to find out what x is. How do I do that? So still same formula. I'm going to plug everything into the distance formula. That's my d. You do not have any problems like this. I want you to get used to, we're using some variables because you have some problems that require you to use variables that are harder than this. So I'm going to plug those in. Oops, forgot my equal sign. Okay, what should my first step be? Oh, I don't like that square root sign, so what I'm going to do is I'm going to square both sides. What is 2 square root of 5 squared? 20. Wherever you square it, this square has to go to both things. So 2 squared is 4. Square root of 5 squared, that your square root sign just cancels out. So you get 4 times 5, which is 20. Now, since these are interchangeable, I wrote this down not how I wanted to write it down. So I'm going to change that order. That looks like I did something really bad as far as algebra goes, right? That negative sign should have stuck with that x. But what I did is I'm rewriting my problem because I don't like how I wrote it the first time. I wanted my x to be first because I don't want to deal with a negative x. Since it's inside the square, that's fine. Doesn't matter. If I did 6 minus 4, I'd end up with 2, right? Whenever I square it, what's this going to end up being? 4. Now, hold off your desire to square that. Reason is, if you square that, you have to FOIL it. If I take that and I square it, what I'm going to do is I'm going to end up with this. That is a mess. Because then that means I'm going to end up having to factor. We haven't covered that. You may remember how to do that, but that's still a lot more work than what we need to be doing. Because if I move that 4 over, how do I get rid of a square? Square root. Okay, there's another trick that I want you to remember whenever you square root. What do you have to do whenever you square root something? Put plus or minus. Because there's 2 numbers you could square to get 16. You could square 4, or you could square -4. So that means I have 2 answers. Now, again, you do not have any problems like that. I wanted to work through a problem like that. You actually have a problem sort of like that that's all variables that I want you to try. It's similar to that. Hopefully it makes sense that you have two things. All right, so I have a point and I have an x value. So this is the line x equals 6. So there are 2 places on this line that would be the same distance from that point. I have one that's up here at 6, 6, and I have one down here at 6, -2. That's why we have to get 2 answers for that question. That makes sense? So both of these would be the same distance. Well, and we know what that distance is. That distance is 2 square root of 5. So we can't just get one answer. All right, but most of your distance formula questions are going to be like that. All right, you good with it? All right, back to something easier. Midpoint. Okay, before I give you the midpoint formula, which most of you may already know, I want you to see how we get the midpoint formula. Okay, again, I'm going to have 2 ordered pairs here. Oops, that's supposed to be a y. Okay, and then I have a midpoint right here in the middle. Okay, now we talked about, when we're talking about horizontal distance, if I want this distance here, I only care about the x values, right? So, this x value here is x1. This x value here is x2. How do I find that middle x value? Add them and divide by 2. Right? Whenever I want to find the middle of anything, what if I had 10 things? How do I find the middle of 10 things? You average them. Whenever you find the average of something, you add them all up and divide by how many you have, right? Well, I only have 2 things. So I'm going to add them up and divide by 2. So same thing with your y values. To find that middle one, you're going to add them up and divide by 2. You're going to average them. There's actually things for finding the average of 3 points and 4 points and more points. You guys just have never dealt with them before. Actually, you may have dealt with the average of 3 points inside of a triangle in geometry. I don't remember what it's called. Circumcenter or incenter, one of those. I don't know. It's been a while. I don't like geometry. But one of those is the average of 3 points. Okay, so midpoint. Now, since it's a point, it's still an ordered pair. Since we're adding them, it doesn't matter what order they go in. Sometimes you see the 2's come first. I should probably put the 2's first because normally that's how you see it. But it doesn't matter because it's addition. Addition is interchangeable, right? It's commutative. So if I do example 3 real quick, midpoint of example 3, 2 plus negative 4 divided by 2. So the x value is going to be, that's negative 2 divided by 2, so negative 1. And then my y values, 6 plus 3 divided by 2. I don't care how you put this. It really doesn't matter. You can leave it as a fraction or you can put it as a decimal. It's either going to be halves or it's going to be 0.5. You really don't have any other options there. I guess it might be, you could if they gave you fractions, but okay, if we do a harder version, I want to find x. Now, this is actually an easy problem. If I want to find x, how do I find it? Yeah. Okay. Let's set it up as a problem, though, just in case we had something harder. Use your formula. Now, the 4 and the 7 don't even matter, right? Since it's an ordered pair, each part of the ordered pair is separate. So then what you said is correct. Whenever I go through the steps here, I'm going to double the 6 and subtract the 3. But for harder problems, we always want to see how to set them up, because again, you're going to be doing this later with only variables. So then whenever I go to solve it, I have 3 plus x equals 12. Subtract the 3, so x is going to be 9. But the nice thing about midpoint again is, since it's ordered pairs, each piece is separate. You don't have to worry about how the x values interact with the y values, because they don't interact at all. Okay, we're almost done. Got one more thing. Anyone still need that? I see a couple people writing. They're just being nice. Okay. Now these. I want you to know, someone is correcting. I want you to know that these exist. Here they are. You are not required to memorize them. You will barely even use them. If you need to use them on a test, you will be given them. I wanted you to know that they were there because there's possibilities throughout this chapter. You may need some of them for some of the homework problems. And I wanted you to know that they existed and where they were. Because on a homework problem, they're not going to give them to you since they presented them in part of the notes for a chapter. So, there you go. Again, some of them you probably already know, like perimeter and area of different things. Some of you may already have volume of certain things memorized, but there's some common ones. I am not requiring you to memorize them. There's going to be way enough stuff that you have to memorize this year to not worry about geometry. Guarantee you it's Miss Lundstrom. All right. As far as homework goes, whenever I enter it into Synergy, I try to, in Synergy, put the homework assignment in the Synergy column. Whenever I enter it in the notes for the assignment, I put the actual assignment. So in Synergy, if you ever click on the assignment, in the notes will be the actual assignment. So if you ever need to look it up there, you can look it up there. And then again, on YouTube, it's there. Also, if you come into class, these notes, I'll have these notes, so the assignment will be there also. These notes back there, I have a red folder that says pre-calc. These notes are kept in there. So you can ask me for the red folder if I'm not in the room. I do not mind if you go back there and grab the red folder. It's on these brown shelves, on the second shelf. It's just right here, it says pre-calc. That's where these notes will always be. And I should probably stop recording at some point.